This video is for lesson 22. This was the homework you did. Lesson 22 was 7 problems. You were on page S99. So in this particular video, I want to go over the questions. Question 1, they were traveling 375 miles per hour. That's the rate. They don't say 1, so it's per 1 hour. So I wrote that as my ratio here, 375 miles over 1 hour. And they say how far would the plane travel if it went 6 hours. So I plugged in 6 here, and I'm trying to figure out then how many miles that would be. Setting it up cross products, multiplying the 2 across that I have, dividing by 1, you would have 2,250 miles. So that was my answer to question 1. Question 2. The mouse is running 360 centimeters for 9 seconds, so that's the ratio. So I labeled 360 centimeters over 9 seconds. And then how fast did it run? So this is one of those questions where we're asking for rate or speed. So when you're looking for rate or how fast somebody went, then in this case, since it's centimeters and seconds, we want to know how many centimeters per 1 second. So because it said how fast, we're looking for rate per 1. Cross products, 360 times 1, then you divide by 9, it would be 40 centimeters per second. So you need the whole part of the ratio, 40 centimeters per second, to get the rate. The third question, 7 seconds to run 350 centimeters. So you've got your time and your distance here. So I wrote these down here for number 3. I put the distance on the top, 350 centimeters over 7. That was the ratio that was given to me here. And then again, I want to know how fast did it run. So then we have to figure out centimeters per 1 second, because how fast is a rate of speed per 1. So we had 350 to 7, so what would it be per 1? You solve cross products again, and then divide by 7. You would have 50 centimeters per 1 second. And that's what I wrote there for number 3. Number 4, the boat's going at a speed of 17.25 miles per hour. That means per 1 hour. This whole thing is the rate. So I wrote number 4's here. 17.25 miles per 1 hour. So this is the rate per 1. Well, then what if they go for 200 hours? Then how far was it? So I have the hours on the bottom, 200. So when I set this up cross products and divide, I would have 3,450 miles. And that's what I wrote for number 4. Number 5, the ratio that you see is 110 mph. That means 110 miles per 1 hour. So I wrote that right here, number 5, 110 miles per 1 hour. And then as you continue on, that's one direction for 2.5 hours. So how far is that? So I put the 2.5 hours down here. And it's okay if you wrote 2.5 or 2.5 hours. Cross products, divide by 1, you would have 275 miles for number 5. Number 6, the ratio is 26.2 miles in 2 hours. They want to know rate of speed. Remember, rate means per 1. So when I set this up, 26.2, this was miles for 2 hours. That's what this ratio is. Then we got to figure out what the miles is per 1. So 26.2 times 1, and then divide by 2, you get 13.1 miles per 1 hour, because rate means per 1. So again, cross products. The last one, 17 centimeters per minute. 17 centimeters per minute. And then if a banana bug slug travels for 5 hours, how far? So this one's a little bit tricky, because we have 17 centimeters per minute, but they said, what if it goes for 5 hours? Well, we can't have minutes here and then write 5 hours there. We need to continue having this be minutes. So we know there's 60 minutes in 1 hour, so how many minutes would be in 5 hours? So I wrote 60 minutes is the same thing. Or for 5 hours, if you take it times 60 minutes, you'd have 300 minutes in the 5 hours. So 300 minutes is equivalent to 5 hours. We don't really want to use the 5 hours anymore. We just want to keep it in minutes. So 17 centimeters in 1 minute, then how many centimeters would it be for 300 minutes, which is equivalent to 5 hours? You're going to get 5,100 centimeters or 5,100 centimeters. So a little tricky on that particular one. The other homework I want to go over was from lesson 23. So you'll need to flip to that page. Lesson 23 was 6 problems, and this was page S102. S102. Number 1, who walks at a faster rate? Someone who's going 60 feet in 10 seconds or someone who's traveling 42 feet in 6 seconds. So I kind of did like purple and black so you can compare the two different people. So 60 feet in 10 seconds, well, if I find their rate, that would be 6 feet per 1 second. Why did I go per 1? Because they asked for rate. So I know this person is traveling 6 feet in 1 second. The one that was going 42 feet in 6 seconds, I wrote that here, and I got to find the rate per 1. So this one travels 7 feet per second. They're going faster because they're traveling 7 feet per second, and this one's only going 6 feet per second. So it's like I got to compare two different ratios and get them both to their rates. So I continue doing that for problem 2. Who walks at a faster rate? 60 feet in 10 seconds, so I did that one in purple. 60 feet in 10 seconds would be 6 feet per 1 second. Or someone for 5 seconds that goes 25 feet. Now they kind of flipped this one around, but I would still put 25 feet on the top, seconds on the bottom, and then figure out how many feet per 1 second. Now that you have both of their rates per 1, who's going faster? The one that's purple, the one that's going 6 feet per second is faster than 5 feet per second. Notice how these are all set up cross products. The third example, the parachute, which one has a slower descent? Which one's going to come down slower? The red parachute falls 10 feet in 4 seconds. So I wrote 10 feet, 4 seconds. And then I found that that would be 2.5 feet per second for its rate. And then the blue parachute was 12 feet in 6 seconds. So 12 feet, 6 seconds simplifies down to 2 to 1. So which one's falling at a slower descent? Which one's coming down slower? The one that's only coming down 2 feet per second. They're coming down slower than somebody who's covering 2.5 feet per second. Continuing on, problem 4, Buffalo, New York receives 22 inches of snow in 12 hours. So I wrote 22 inches in 12 hours. So when I find its rate, that's 1.83 inches per hour. And then Oswego, New York has 31 inches of snow in 15 hours. So I wrote 31 inches in 15 hours, and its rate ends up being 2.07 inches per 1 hour. So which one has a heavier snowfall rate? It would be this one over here. The Oswego, New York has a heavier snowfall rate. It did say round your answers to the nearest 100, which is why both of mine go 2 places out. Number 5, a marlin swims at a rate of 70 miles per hour. So that's already the rate, 70 miles per 1 hour. You don't have to do anything else. It's already per 1. Is this faster or slower than the sailfish, which takes 30 minutes to swim 40 miles? So I'm going to change this so that I have miles on the top, and this had 30 minutes. I want to change it so that I am comparing it like I did over here per hour. So I know they said 30 minutes, 40 miles, but I wrote it 40 miles in 30 minutes. If I double that, then that would be 80 miles in 60 minutes. And 60 minutes is equivalent to 1 hour. So instead of saying 80 miles in 60 minutes, I could say 80 miles in 1 hour. And so the question was asking, is the striped marlin swimming faster or slower than the sailfish? Well, 70 miles an hour is slower than the sailfish, which was 80 miles an hour. The last example, one math student can solve 6 math problems in 20 minutes, where the other one could solve the 6 math problems at a rate of 1 problem per 4 minutes. So let's talk about this. 6 math problems in 20 minutes. So I wrote 6 problems, 20 minutes. So I got it down per minute, per 1. So 6 times 1 is 6, divided by 20. That's only 0.3 problems in a minute. Then the other person said 1 problem in 4 minutes, so 1 problem in 4 minutes. Can I make it, then how many problems would that be per minute, per 1, like I did here, compare their rates per 1. So 1 times 1 divided by 4. This one solves 0.25 problems per minute. So in 1 minute, which one's going a little faster or solving a little bit more of a problem in the minute? The first person would be.